Welcome to this training module on firefighting process hazards, an essential component of the advanced firefighting course prescribed under Section A6/3 of the STCW Code. In this lesson, we will focus on four critical hazards: dry distillation, chemical reactions, boiler uptake fires, and fires involving water tube boilers. This module will guide you through these hazards, explain how they develop, and demonstrate the measures required to prevent, control, and extinguish them. Process hazards differ from ordinary fires because they originate from internal chemical or thermal changes within machinery, fuels, and structural materials. Let us examine each major hazard, beginning with dry distillation. Dry distillation is the decomposition of organic materials such as wood, oily rags, paint residues, insulation, or cargo when exposed to high heat in the absence of sufficient oxygen. As temperature rises, the material releases flammable vapors. These vapors accumulate unseen, and when oxygen becomes available, they may ignite violently. Common shipboard locations include 1. Wooden gratings and insulation near hot machinery. 2. Paint stores exposed to heat. 3. Cargoes like coal, wood products, or oily waste undergoing slow heating. Control measures include strict housekeeping, avoiding accumulation of combustible materials, ensuring proper insulation of heated machinery, and maintaining adequate ventilation. Engine room personnel must monitor surface temperatures, remove oily waste promptly, and secure all flammable materials in designated storage areas. Early detection prevents the conditions that allow dry distillation to occur. Chemical reaction hazards arise when substances react with air, moisture, or other chemicals producing heat, toxic gases, or flammable vapors. Examples include 1. Spontaneous combustion of oily cotton waste. 2. Reaction of alkali metals with water. 3. Exothermic reactions in paint locker chemicals. 4. Polymerization or decomposition reactions in cargoes. Because the reaction may begin unnoticed, fires can erupt suddenly and spread rapidly. To control chemical reaction hazards, all materials must be stored and handled in accordance with their material safety data sheets. Segregation of incompatible materials, maintaining cool and ventilated storage spaces, and regular inspection for leaks or heat buildup are essential procedures. A boiler uptake fire occurs when unburnt fuel particles and soot accumulate in the boiler's uptake or exhaust passages, igniting due to high temperatures. This happens when combustion is incomplete, often due to poor atomization, incorrect air-fuel ratio, or fouled burners. Once ignited, soot can burn intensely, heat metal surfaces to dangerous levels, and potentially lead to uptake explosion if gases accumulate. When an uptake fire is detected, the boiler must be handled with extreme caution. Control measures include 1. Reducing boiler load. 2. Stopping the burner safely. 3. Maintaining forced draft to prevent backflow of flames. 4. Closing air registers only as per recommended procedures. 5. Never opening manholes or access doors while the uptake is hot. Routine soot blowing, proper burner maintenance, and combustion monitoring are key preventative practices. In a water tube boiler, the risk is more severe due to its high-pressure steam system. A fire may originate from the furnace or from rapidly rising temperatures caused by flame impingement or fuel malfunctions. Overheating of tubes can lead to evaporation of water, tube deformation, rupture, or even explosion if cooling is not restored. To control a water tube boiler fire, the priority is to stabilize water levels and cut off fuel safely. Cooling the furnace must be done gradually, never by spraying water directly on the hot surfaces. Engineers must follow the manufacturer's emergency shutdown procedures and monitor boiler pressure continuously. Preventive maintenance, routine burn tests, and strict fuel management significantly reduce this hazard. In every process hazard scenario, early detection is the most powerful safety measure. Good engineering practices, cleanliness, machinery monitoring, chemical control, and boiler maintenance form the foundation of prevention. All crew members must remain vigilant, report abnormal heat sources, and follow proper shutdown and isolation procedures. Firefighting process hazards present unique challenges that require awareness, discipline, and technical competence. By understanding the nature of dry distillation, chemical reactions, boiler uptake fires, and water tube boiler fires, and applying the correct control measures, you enhance the safety of your vessel, your shipmates, and yourself.